Hello everyone, in this video let's discuss about D flip-flop. If you are new to our channel, please subscribe for more engineering related topics. D flip-flop means the D represents data or delay flip-flop. Data or delay flip-flop. To get full marks in D flip-flop question, so we will follow 5 steps. So first one is block diagram. Using this block diagram, the second step, that is we will draw the circuit diagram. Using block diagram, we will draw the circuit diagram. Next, using the circuit diagram, we will construct the truth table. Using this truth table, we will construct the characteristics table. Using this characteristic table, we will construct the excitation table. So these are all of very simple processes. So you can get full marks by following this 5 steps. First step is what? Constructing the block diagram. In block diagram, we will simply represent the inputs and outputs. Block diagram. So in every flip-flops, we will be having 2 outputs. So one output will be Q, another output will be Q bar. So you can represent it using A bar, B bar, like that also. So what Q and Q bar represent is, if Q value is 0, Q bar value will be 1. If Q value is 1 and Q bar value will be 0, that is whatever the output comes here, this output must be the complement of that one. That is, no two output must be same. Both must be complement of each other. So in delay flip-flop, we will be having 2 inputs. In every flip-flop, we will be having clock as the common input. So clock will be represented using CLK. Clock is the common input in all types of flip-flop. So another input is D, that is delay or data. So now we constructed the block diagram. Now using this block diagram, we must construct the circuit diagram. To construct the circuit diagram, we can use NAND gates or NOR gates. Now let's use NAND gate. First let's construct the latch, then construct the flip-flop. First, so this will be Q, this will be Q bar, output Q and Q bar. This output will be given as input to this NAND gate, and this output will be given as input to this NAND gate. Now this is the latch structure. Now we need the flip-flop. So we will add another NAND gates. And I already said clock is the common input in all flip-flop and its value will be constant, that is 1. So every time the clock value will be equal to 1. Now another input is D. So in D flip-flop, if one input is D, another one will be the complement of D, that is NOT gate will be added. Therefore, if I give 0, 0 will go to this NAND gate, but complement of 0, that is 1, will go to this NAND gate, like this. We must use NAND gate. So we must use the NOT gate in between the inputs. So using this circuit diagram, we must write the truth table. So while writing the truth table, we already know the clock value will not change, that is it will always be equal to 1. So since we add only 2 inputs and clock value will always be equal to 1, there will be only one single input and only one single output. Output will be the new state, or this we can call it as new state output. So since we have only one input, what will be the combination? 0 and 1. So if D is 0, that is no input is given, means then the new state output will be 0. If D value is 1, the output value will also be equal to 1. Now using this truth table, let's construct the characteristics table. So in characteristics table, we will use 2 inputs, that are first one will be D, second will be Qn. What is Qn? Qn is the previous state output. Qn is previous state output. So since we have two inputs, what will be the combination? 0 0, 0 1, 1 0 and 1 1. So I already said, to construct the characteristic table, take the reference of truth table. So when the D value is 0, whatever the situation, the output Qn plus 1, that is next state output, will be 0. When D value is 0, whatever the previous state output is there, the new state output will be 0. When the input is 1, that is D value is equal to 1, whatever the previous state output will be, the new state output will be equal to 1. Now the final step, that is, let's construct the excitation table. Excitation table. So before that, let's write the characteristic equation. We must write the characteristic equation to the output, that is Qn plus 1. So I already said, when D value is equal to 1, whatever the situation, the output will be 1. So we can write D as the output. Now to write the excitation table, we need two inputs, that are previous state output Qn and new state output or present state output Qn plus 1. So what will be the output of this excitation table? D. Since we have two inputs, what will be the combination? 0 0, 0 1, 1 0 and 1 1. So when Qn value is equal to 0, Qn plus 1 value is equal to 0, D value is equal to 0. To construct excitation table, take the reference of characteristics table. So when Qn value is equal to 0, Qn plus 1 value is equal to 0, D value is 0. Next, when Qn value is equal to 0, Qn plus 1 value is equal to 1, D value is equal to 1. Next, when Qn value is equal to 1 and Qn plus 1 value is equal to 0, D value is equal to 0. When Qn value is equal to 1, Qn plus 1 value is equal to 1, D value is equal to 1. So this is the excitation table. So if you write these 5 steps, you will get full marks in D flip-flop. Hope you understood the concept of the D flip-flop or delay flip-flop. If you have any doubt, please comment below. If you like the video, please subscribe and like. Thank you.